Ever wonder what it takes to make a weather forecast? Well, if you break it down, you really need three things: a sophisticated mathematical model with equations that precisely describe how the atmosphere works, a fast supercomputer to run all of those calculations quickly, and accurate observations that describe the current atmospheric conditions at the Earth's surface, but especially at upper levels of the atmosphere. Where do these observations come from? Surface data comes from weather stations over land and buoys over the ocean. Observations at upper levels comes from radars, satellites, and aircrafts. But the most important source of upper air observations comes from weather balloons. But while weather balloons are fun and get all the glory, the most important part of the weather balloon is hanging on a string underneath, called the radiosonde. Radio, because it uses a UHF radio transmitter, and sonde from the French meaning probe. The radiosonde carries sensors that measure temperature, air pressure, humidity, and GPS location from which winds and altitude are calculated. The radio transmitter sends that information back to ground stations where the data are collected and used for forecasts. Here is one example of the data that we get, called a sounding. As the balloon rises, we pay careful attention to the temperature, where it is warmer to the right and colder to the left. The air temperature is the red line, and the dew point is the green line. The dew point is a way of measuring the humidity, and the difference between the two lines tells us where the air is dry versus where the air is saturated. As you can imagine, it is normal to expect that the higher you go, the colder it gets, which is what we can see in this graph. It's interesting to note, however, that really high up, it begins to get warmer again once you enter the stratosphere. This particular sounding tells scientists to watch out for severe weather, including tornadoes. Here is another example that many in Colorado know as the brown cloud, called an inversion. Here you can see at the beginning of the launch, near the surface, it's actually getting warmer as it rises. Then we can see where it immediately gets colder. This is where the colder layer of smog is trapped below the warmer air above. But that's not all the data are used for. We use it for local severe storm prediction, aviation, and marine forecasts. Field programs to study specific atmospheric phenomena like severe thunderstorms, tornadoes, monsoons, and hurricanes. It's used for ground truthing, where observations are compared to check the accuracy of radar and satellite data. And the data are also plugged into many different kinds of useful modeling tools, which can help predict river and stream levels, the onset of drought, pollution and air quality, and even the spread of certain mosquito-borne diseases. 92 sites in the U.S. launch weather balloons simultaneously twice a day. This is part of the global Radiosonde network, with over 900 sites that provide the observations to accurately describe our current weather and make accurate future forecasts.